In binomial theorem, I divided IP questions into three parts. This is for senior intermediate, for intermediate board of examination. The first part contains only basic questions. The second part is related to the binomial quotients. These two theorems I am doing now. The third part is infinite series models. So in this model, I am considering only two questions. That is the first question, this one, and second one is this one. So let us do the first one now. Now first one is once see this one. Let us consider the left hand side. What is the left hand side? Left hand side is given as C0, C1 x by 2 plus C2 x squared by 3 plus C3 x power C3 x cubed by 4 plus and so on plus Cn x power n by n plus 1. That is the left hand side is given. So let us write that clearly. What is NC0? That is C0 is NC0, NC1 into x by 2, NC2, C2 is NC2 into x squared by 3 plus and so on plus last term is NCn x power n by n plus 1. So that is equal to NC0. NC0 we can write that one as 1. NC1 is n, right? X by 2. What is NC2? N into n minus 1 by 2 factorial into 1 by 3. Here is nothing is there, we can write that one as 1 factorial. Plus next, can you guess the next one? NC3 x cubed by 4, right? So NC3 means that n into n minus 1 into n minus 2 by 3 factorial into x cubed by 4 plus and so on. Last one is x power n by n plus 1. Listen to me carefully here. We can write 1 plus, this is n by 2 factorial into 2 into 1 factorial. 2 into 1 factorial is 2 factorial. 3 into 2 factorial is 3 factorial. So because n into n plus n minus 1 factorial is n factorial only. Okay. So that's why I am writing this one as x is as it is plus this is n into n minus 1 by 3 factorial, because 3 into 2 is 3 factorial. Next one, can you guess that? N into n minus 1 into n minus 2 by 4 into 3 factorial is 4 factorial x cube. Here I forgot to write x square. Last term is x power n by n plus 1. Now let us multiply and divide this one by n plus 1 into x. Multiply and division by divided by, what is that? N plus 1. Why we need to multiply and divide it by this one? Once observe the right hand side. In the right hand side, the denominator is n plus 1 into x, right? So that's why I am multiplying and divided by n plus 1 into x. So that is n plus 1 into x. So I divide it, right? So 1 into n plus 1x. Next term is n plus 1 comes to this term, right? So what it becomes? N plus 1 into n by 2 factorial into x is x square. Next term is n plus 1 into n minus 1 by 3 factorial into x cube plus and so on plus last term is n plus 1 into x power n plus 1 by n plus 1. Once observe that these two get cancelled. So once you see this one, now how we are going to convert this one into the right hand side. This is 1 by n plus 1 into x. So n plus 1 can be written as n plus 1 c1 into x. This is n plus 1 c2 into x square. This is this term. Next term is n plus 1 c3 into x cube plus and so on plus last term is n plus 1 cn plus 1 into x power n plus 1. Once observe that the expansion of this one. So it is 1 plus x whole power n is nc0 plus nc1x plus nc2x square plus nc3x cube. Last term is ncn x power n. Can you guess what is the expansion of 1 plus x whole power n plus 1? Instead of n, we have to write n plus 1 c0 plus n plus 1 c1x plus n plus 1 c2x square plus and so on. Last one is n plus 1 cn plus 1 x power n plus 1. These are the expansions of this one. Okay, now let us check that. What is our last step? N plus 1 c1. So n plus 1 c1 means that it starts with this one, right? We don't have this term. So adding and subtracting n plus 1 c0 now. What is that value? N plus 1 c0 is nc0, that is 1. Okay. So adding and subtracting n plus 1 c0, which is equal to 1. So I am adding that. So left hand side becomes 1 by n plus 1 into x as it is. What we have? Yeah, n plus 1 c0 is added now. What is the next term? Next term is this one only. So n plus 1 c1x plus n plus 1 c2x square plus and so on plus last one is n plus 1 plus n plus 1 c n plus 1 x power n plus 1. Here we added, right? We are subtracting the same term, that is 1 only. So now observe that 1 by n plus 1 times of x. So till this term except minus 1, it becomes 1 plus x whole power n plus 1. I wrote this expansion also. Till n plus 1 c n plus 1. So till here, that is this one. So minus 1. So that is equal to 1 plus x whole power n plus 1 minus 1 by n plus 1 into x. So hence prove that is right hand side. So let us go for the next question. Next question is for that one we need to consider this one, n1 plus x whole power n. What is the expansion of this one? c0 plus c1x plus c2x square plus c3x cube plus and so on plus cr x power r, or else we can consider the previous term as cr minus 1 x power r minus 1 plus cr x power r plus cr plus 1 x power r plus 1 plus and so on plus cn x power n. So writing that same terms from the right hand side. Right hand side, what we have? c0 x power n plus c1 x power n minus 1 plus c2 x power n minus 2 plus and so on plus cr x power n minus r plus and so on plus last term is cn. So these terms are same only. Okay. So let us, what I am going to do that, multiply these two now. Let it be first equation and this is the second equation. Multiplying these two. 1 into 2. First let us write the right hand sides first. In the right hand side we can, left hand sides first. These right hand side should be multiplied first. 1 into 2 implies that first c0 plus c1x plus c2, more careful about that, plus c3x cube plus c3, you don't need to write, let us write cr minus 1 x power r minus 1 plus cr x power r plus cr plus 1 x power r plus 1 plus and so on plus cn x power n. This is the right hand side of the first equation. So right hand side of the second equation is c0 x power n plus c1 x power n minus 1 plus and so on plus cr x power n minus r plus cr plus 1 x power n minus half r plus 1 plus and so on plus cn. The right hand side is 1 plus x whole power n into x plus, this is the main step. What I am going to write is the main step now. Once observe that what we need in the right hand side, c0 cr. One c0 cr is there. Where is c0? This is c0. This is cr, right? Multiply these two. What we need, that is a c0 cr, we got that. Next c1, this one, cr plus 1. So what is the quotient of x in these terms? When you multiply c0 with cr, the quotient of x is x power n minus r. When you multiply with c1 with cr plus 1, the quotient is x power again n minus r only. So it is better to compare. Now comparing the quotients of x power n minus r. Comparing the quotients of x power n minus r. So C0 CR will get x power n minus r. C0 CR. The next one is C1 CR plus 1. What will you get? Quotient of x power n minus r plus and so on plus. What is the last term? This is Cn, right? So previous term is Cn minus r. So this is the quotient of x power n minus r in the left hand side is equal to quotient of x power n minus r in right hand side also. If you multiply this one, it becomes 1 plus x whole power 2n. So quotient of this one is what is the quotient of n minus r in this one? That is equal to 2nc n minus r. 2nc n minus r. So 2nc n minus r can be written as 2n minus of n minus r. That is equal to 2nc n plus r, because ncr is equal to nc n minus r, because ncr is equal to nc n minus r. Therefore c0 cr plus c1 cr minus r plus 1 plus and so on plus cn minus r cn is equal to 2nc n plus r. So now deductions are also there. Deductions are simply substituting r is equal to 0 and r is equal to 1. Substitute r is equal to 0. What will you get? C0 into C0 plus C1 into C1 plus and so on plus Cn into Cn is equal to 2n Cn. What is that? C0 square plus C1 square plus and so on plus Cn square is equal to 2n Cn. Substituting r is equal to 1, we will get the second one. C0 C1 plus C1 C2 plus C2 C3 plus and so on plus Cn minus 1 Cn is equal to 2n Cn plus 1. So this completes these two questions.